Okay, so why are there 360 degrees in a circle? By definition, why 350? Why 360? Nobody really knows. There's some different answers to that. One of the reasons people say is, well, there's 365 days in a year, and that had to do with, just where like our rotation around the sun, that kind of thing, right? So that kind of worked itself out. So 360 is close to 365. That may have something to do with it. A good guess is, if you think about 36, it's divisible by a lot of things. It has a lot of factors. If you look at all the numbers up to 36, like 36 has a ton of factors in it. And so 360 does as well. So maybe it's because it's a nice number that's got a lot of factors in it, they decided to go with that. But really, 360 degrees in a circle it's made up. It's by definition. You take a circle, you split it up into 360 even segments, and one of those segments is 1 degree, right? That's the unit. So that's 1 unit, and that's the unit that you've used to measure angles. But there's another unit, and it's called the radian. So it is a different unit for measuring angles, just like an inch is different from a centimeter. You would tend to use those things to measure the same kinds of things, an inch or a centimeter, but they're different. So you need more centimeters than you need inches for something. So that's like what a radian is. It's a unit of measurement. It's nice because it is unit. When we say it has no unit, I mean, it is the unit. You'll maybe understand what we mean by that down the road. It's just a ratio, though. This is what's nice. It's a ratio of the arc length of a segment of a circle to its radius. So it doesn't have a unit like 360 of them go into a circle. It's not a unit like that. It's a different kind of measurement tool, which it does tend to be something that people, not everybody, but it's kind of famously tricky to work with when you're learning. But because it's unitless, it ends up being very, very, very powerful for mathematicians and in physics. They love the radian because of how easy it is to work with once you get used to working with it. One thing to think about, and we'll talk about this again in the last example today, but something that's interesting to think about is, like, just generally, what is an angle, right? Like, what is a measurement, of an angle? Because if I draw an angle like this, and let's say I take this point and I rotate it, and I take this point and I rotate it, there's a length here and there's a length there, and they are not the same. So the point on the arm travels a different distance, but the rotational angle is the same for both, right? So it's a different kind of measurement. They've rotated the same number of whatever unit you're talking about, degrees or radians, but the distance the point on that arm has traveled is different depending on how far out you go, right? That's something that you probably sort of had applied in situations before, but it's that thing where, like, if y'all link up arms and you spin, the person on the end has to go a lot faster than the person on the inside, right? And you can kind of throw them. So anyway. Okay, so let's talk about this. So here's what you probably want to write this down. What the heck do you mean by ratio of arc length to radius? What does that even mean? This is where we start to hopefully define and understand what radian is. Okay, so this is the radius. And this length here we're going to call it A for the arc length. So in this case, I think you can tell just visually, we're not calculating anything. A is smaller than R. And if I divide both sides by R, I get A over R is less than 1. So the ratio of the arc length to the radius is less than 1. In this case, just a made-up case. Nothing profound happening here. Okay, same thing. I've got R. I've got A, which is the dark black, obviously, so it goes all the way around. So what do we notice about this case? Well, A is greater than R. So the ratio is greater than 1. You agree? Does that make sense? You'll have to take my word for it. But in this case, what if I tell you that A is equal to R? So the arc length is equal to the radius. The angle that gives you that is 1 radian. And if you go back to that little animation, that makes sense, right? You took the radius, it flipped it up, and then mapped it onto the circumference of the circle, right? So there's radian. So this is A over R equals 1. So that's 1 radian. We call it, or rad for short. Here's what we mean by it's unitless. If I have A centimeters equals R centimeters, when I move it over, I get A centimeters over R centimeters equals 1. The centimeters cancel, and so we end up with like no unit. It's a ratio. Sure. Does that make sense? You happy with that? Okay, so now we have the definition of what a radian is. It's a ratio. Why do we do this? Like as you're struggling through the math involved with radians, that question's gonna pop into your head. Why can't we go back to degrees? They were so much easier. But again, it turns out if you get good at them and if you take this further, they're a very convenient way of doing things. They are better in a lot of ways than degrees. Unfortunately, that's not something you'd necessarily experience, I think, in high school. You might not agree with that, but in the long run, it does turn out to be that way. Okay, so this is a little formula that you need to know. The angle measured in radians can be found by dividing the arc length, why the H is missing there, I don't know, by the radius. So A divided by R will give you the angle theta measured in radians. So if you're writing radians, you don't put the little degree symbol, right? Like that is the unit for degrees. We wouldn't use that anymore. We'd call it rads now. Does that make sense? This is what we're doing. Okay, so what about for a full circle? This is something that's good to know. Oops, for a full circle. The angle is A over R, right? We just established that. That's our formula. What is the arc length of a full circle? It's the circumference, which we already talked about is 2 times pi times the radius, 2 pi r. So theta is 2 pi r over r. Again, we see that those cancel. And we saw this in that animation. But the measurement in radians of a full circle is 2 pi. Why is that important? Well, if you think back to trigonometry in grade 11, knowing that 360 is one full cycle, one full rotation, one full period, that's an important number to know. And then we also have all these other sort of anchor points like 180 and 90, and we have these other special angles in particular that we know. We do the same thing for radians. We have to start to get familiar with these important measurements. So a full circle is 2 pi. A half circle would be? Pi. 180 degrees is pi, right? So we can start to write out some of these. We're going to write all of them out in a minute. 2 pi is the same as 360 degrees. So 1 pi is the same as 180 degrees. And that means pi over 180 is 1. What does that mean? 1 degree is equal to pi over 180 radians. Not necessarily something that's all that useful for us. Well, it kind of will be, but like it's not something that you necessarily, I don't know, remember by definition, but it turns out that that's how it works out. Any questions? Let's keep going. Let's get to some actually doing some stuff here. So one of the things we're going to learn how to do is how to convert between degrees and radians. That's kind of one of the important things that we're learning today. And the reason for that, well, it's just one of the things that we learn in grade 12. But also, this way, as you're learning to use radians throughout this unit, the better you are at converting back and forth, the easier it is for you, because your brain is going to maybe resort back to degrees often. Like you're going to want to think about things in degrees. So if you can convert back and forth quickly, you can take advantage of your understanding of these problems in degrees and use them to kind of cheat. So it's kind of like when you're learning a second language, when you're first learning, so a lot of people learn French, right? In elementary school, you take core French. Your brain translates everything back to English. So somebody says something, you translate it to English in your head, you think about what it means, you think about your response, you translate that back to French, and then you give your response. And if you study it long enough, becoming bilingual means you start thinking in French. Kind of the same for this, I would say. In the beginning, you might be inclined to try to convert everything back to degrees and work with degrees and then convert everything back to radians. Now, you're not going to be allowed to do that on paper, but you could do that in your head to make sense of it. But all of our answers basically from here on in will be in radians, and all of your work will have to be shown in radians. But you may think of it that way. But eventually, if you work with it, you should get to a point where you're thinking in radians more than trying to convert back to degrees. Okay. All right. So how do we do it? Converting to degrees, there's a cheat, and you just take pi when you see it. Although this fails us once in a while, because once in a while you have to convert and there is no pi, and then people don't know how to do it. But I'll show you how to do that in a second. So you replace pi with 180, and then you can just do it. So 4 pi by 5 is 4 times 180 divided by 5. And so that works out to 4 times 180 is 720 over 5, which is 144. We're converting 2 degrees, so 144 degrees. But essentially what we did is we multiplied by 180 over pi. So that's how you convert 2 degrees. But in every case, those will cancel. If you have a pi in it, those will cancel, and you end up with 4 times 180 over 5. That's why replacing pi with 180 works. Occasionally, you're going to be asked to convert something like 3 over 2 radians to degrees. Like that's something that you could do. You'd have to fall back to this method where you multiply by 180 over pi. So there's something you should probably be aware of, but we often cheat because it doesn't come up very often. There's almost always a pi in the number that we're working with. How do we convert to 130 degrees? We multiply by pi over 180. So again, notice it's the opposite. We multiply by 180 over pi to get to degrees. We multiply by pi over 180 to get to radians. So it's an easy thing to remember. And again, that's because of this. It's because of the ratio between, and because of this, right? It's the ratio between the two units of measurement. So this is going to be equal, so 130 times pi over 180, which is 130 pi by 180. That's how we write it. And always, always, always we reduce. This one can only be reduced, divide the top and bottom by 10. So one of the main reasons why I think why people find radians difficult is because their fraction skills aren't that great. And everything in radians has to do with fractions. So you're just going to have to practice over the next little bit working with fractions and thinking in fractions. Yes?
So why do we use 180 over pi? And then
Because that is the ratio, or that's the relationship between radians and degrees. So there's two answers to that. One is don't worry about it, just try to remember it and just do it. But the other one is, the answer is right here. But that may not be a great answer for you yet. So don't don't worry too much about it. Think about it after we've kind of started working with this a little bit. Okay, but that's the answer right there. All right, so let's do a little bit of this. I want you to do this. Now, if you printed this out ahead of time, I did change it a little bit, so you can either do what you have, or you can try to sort of change it, do it on the back or something, and do it this way, or you can look it up online after, whatever you want. Here's what I want you to do. If this is 180, what's pi by 2? 90, thank you. Degrees. You know what? This should be, we often don't write this, but this is like radians, rad for radians. The textbook always does. We don't always have to, but if you were required to write a unit, for some reason, if you were trying to be specific or clear, you would write RAD for radians. Okay, so try to fill out some of the rest of this. See if you can work through a little bit more of it. Always, in this case, we're always kind of starting with 180. As I think of it as like an anchor point. Like my anchor of understanding is pi is the same as 180 degrees. How can I turn that into these other common fractions that you might see? And a tip that I'll give you is if an activity like this kind of makes you go like, I don't really want to do this right now. It seems kind of hard and I don't know, fractions. I'll figure it out when I have to. That's the wrong attitude. Like you got to do, with these fractions, you just have to do it. You have to force yourself to do it, even if it feels like something you don't want to do. And then you'll get good at it. If you force yourself to work with it a little bit and think about it, you'll get good at it. And of course, you're allowed to use your calculator now, but remember, we're going to eventually do this with no calculators. So you can ask, how would I do this without a calculator? I wouldn't expect you to be able to do it today, but after you've done it a little bit, then yes. You should be able to, you will be able to, if you do the work. So what's pi by 3? Eric? 60. What's pi by 4? Yep, okay. 45. How'd you get that? Nice. What's another way you could get that? Yeah, so divide by 2, that gives you the 90. Pi by 2 divided by 2 is 45. That's the understanding that you want to get to eventually. Because that's what you would do with the numbers. Right? If it was half of 90, You wouldn't be, okay, well, I'll go to 180 and divide by 4. No, you just divide it by 2, right? And that's the relationship you want to see as well. So what's pi by 6? Yep. And how did you get that? Nice. So it's half, pi by 6 is half of pi by 3. And again, there's the problem, is people aren't good enough at fractions typically that they see that. That 1 over 6 is half of 1 over 3. We don't see it that way. But you want to get to the point where you do. And if you do, then this is easy. Really easy. And a lot of people do. You might think, I've always hated fractions. No, trust me. This is when you actually finally are forced to work with fractions a little bit and you can get a lot better at it. Okay? And some of you probably already don't find it too bad. So you could also do 180 divided by 6. Like, you can always go back. And 180 divided by 6 isn't so bad because 18 divided by 6 is 3. Like, I can do that, right? That's super easy. Okay, what about pi by 9? So 20. So again, 18 divided by 9 is 2. And then what about pi by 12? 15. So what I would have done there, right, is pi by 6 divided by 2 gives me the 15. Nice. Okay, let's keep going. So pi by 3, we've already figured that out. That's 60. So what would 2 pi by 3 be? $120. How'd you get that? 180? Yeah. Take 180, multiply by 2, and divide by 3. Very good. What's another way that you could get that? Bishoy?
Well, since 180 divided by 3 is 60, and 2 times 180 is 360, and that's divided by 3, so it's losing half of that.
Yep. Okay, good. Does anybody want to add to that? Multiply by 2, right? So if I know pi by 3 is 60, like, you want to get some of these that you just know. 2 pi by 3s is 2 60s, right? 2 pi by 3 is the same as 2 times pi by 3. Like, you have to see that. 2 60s is 120. What's 3 60s? 180. And what's 3 pi by 3? 3 over 3 gone. It's pi. You see the relationships here? You see what's happening? Everybody loves pi. What's 4 pi by 3? 240. How'd you get that? Yeah. Which was what? 60 times 4. Pi by 3 multiplied by 4. Or since we already have 2 pi by 3, you can multiply by 2. Like, I don't know. There's no right or wrong answer here. This is understanding relationships. So 5 pi by 3. Take pi by 3, multiply by 5, so 300. 6 pi by 3, well, that's 2. That's 2 pi. So that's 360. Okay, and you can do this for all of them. So this is 90. I divide it by 2. Multiply back by 2, I get 180 again, but 2 over 2 is gone, so that's just pi. Like, this isn't what we do. This is making connections. This is understanding, right? So that we can get good at working with this stuff. 3 pi by 2, so that's going to be 270. And 4 pi by 2, well, there's a 2 pi again. So that's 360 degrees. And there's your, well, we didn't do 0, but 90, 180, 270, 360, right? So think about how important it is to know, like, which quadrant you're in. So knowing those points. All right, let's try another one. What's pi by 4? Like, we already did that. It's over here. So 45. 2 pi by 4, I multiply that by 2, I get 90. But 2 pi by 4 is the same as pi by 2. Right? 3 pi by 4, so add another 45, so that's 135. We skipped 4 pi by 4, so 5 pi by 4 is adding 45 to 180. Like, see how you can, when you start to be able to interchange, right? So 225. What's 6 pi by 4? Add another 45. 6 pi by 4 is the same as 3 pi by 2. 270. 7 pi by 4, 315. And so on. We're going to come back to this again. I'm going to give you a little a sheet that you can fill out to help you think about all this. Okay, let's do a little bit of practice. Try both of those. See if you can remember how to do it from a few minutes ago. The other thing I'll say is try not to get intimidated, like try not to back off. Work with it. It does take time, but don't be intimidated. Don't quit. It will come. Okay, it does, just like everything else. Seems hard at first. Persevere. You get better. Who can remind me how to convert to radians? Alex? So this is going to be 120 pi over 180. What does that reduce to? Go ahead, Alex. 2 pi by 3. Good. And how about this one? What does it reduce to? Alicia, can you tell me that one? Nice. So again, for some of this, like you can use your calculator, but you may have to do this without a calculator at some point. So I would test yourself at some point. Okay, try those. How do I convert to degrees? Sub 180 in for pi, so 2 times 180 divided by 3, or more specifically, multiply by 180 over pi, right? Just the reciprocal of what you do to convert to radians. So that's 360 over 3, 120 degrees. Go back to that last activity. What's pi by 3? It's 60. I got 2 of those. I got 120. Okay, 7 pi by 8. What does this one work out to? Zoe? Thank you. Very nice. And the last one. Oops. 3 times 180. Justin? Oh, go for it. Yeah. I mean, That's not the hardest thing that you would have to do in this class if you did, but that's not the kind of thing that I'd be testing for. So I'm not trying to challenge you with mental math. I'm trying to make sure you understand it. You're not just cheating with your calculator. The other thing is, if you're using your calculator, it's a good thing to do, but you can also check your answers, like work backwards. So, if we take the calculator away entirely, then it's just your understanding. That's what we're shooting for. So I don't know, maybe not. But if it did, you'd probably be able to figure it out somehow, right? But it wouldn't get crazy hard, like 0.612 or nothing. Okay, so 3 times 180 works out to 540. Does that make sense? If any of you know anything about, spinning on a skateboard or a snowboard or something like that, then a 540 is sort of 3 half turns, right? So it makes sense, because think about the circle. 2 pi is all the way around once, so 1 more pi is around another half, right? So that's 540. Okay. These are just questions you see in textbooks kind of thing. They remind us that we want to understand where a radian comes from. So when in doubt, you could always draw it. It's got a radius of 8. Whoops, why did I write A? 8. And an arc length. Just color that in, I guess. It's smaller, of 5. And what is our formula? Arc length over radius, which is 5 over 8. Which works out to, if you do it on your calculator, 0.625 radians. Theta was just measured in radians. And I think this is a moment where you kind of come back like, okay, well, I don't even know what that means. Wait a minute. But what if I told you it was 40 degrees? Oh, okay, so that's I've rotated a little bit. 40 degrees, right? So 0.625 is just a measurement like that. It's less than a radian. It's more than half a radian. Does that make sense? Okay, next one. Determine the arc length made by an angle of 60 degrees in a circle with a radius of 9 meters. So this one can be important for some of the sort of word problems that we end up doing. Now our formula is in radians. Theta is radians. Theta is not degrees. That will not work for degrees. So 60 degrees is what in radians? Yeah, 1 pi by 3, so pi by 3. So that's my angle. Again, I think it seems strange at first to think of that as a measurement of an angle, but it is. And I'm finding out the arc length over 9. So I just multiply both sides by 9. And I get 9 pi over 3 is A. So that's 3 pi, which works out to about 9.42 meters. Any questions? So that's radians in a nutshell. You want to know how to convert. You want to understand the conversion factor. Understand those anchor points. Start to get familiar with them. That's what you're working on over the next little while. So tomorrow, we take radians and we start answering questions with them like we were doing yesterday. That's what's coming. But today, you're just getting a little bit used to working with radians. Okay, so we got one more question here. It's an application. These angular velocity applications can be a little bit tricky because they're all a little bit different, and I don't know, they require, like, there's no one way to do it. So I think there's a couple assigned in the practice tonight. I really recommend you spend some time convincing yourself how they work, like thinking about it. And if you have to ask about it afterwards, ask me about it, right? But they're not actually hard. Like, the math is really easy. It's just setting it up can be a little bit tricky, thinking about the relationship. So let's give it a try. A 2-meter long arm in a vat. That's like a giant bucket things. Here's a gross story. So about 7 years ago, I spent a few months in Zambia in Africa. And we went on this tour. It was an interesting trip. We were there to adopt our son. So it was like a hard trip, but we did a couple of fun things while we were there. And so one of the fun things we did, we went on this like safari thing. And it was like a safari, so they had like elephants and giraffe. It was really, really neat. And then they also had a cheese factory. I don't know why. So we went on a wine and cheese tasting thing. But at the cheese factory, they had these giant vats that were like spinning, the milk or whatever. But they were open, and there were no like windows or anything. So they're like crickets jumping around. And you can imagine they would jump right into that vat and just get sucked right into the cheese. But they'd get, I was like, okay, interesting. What brand of cheese is this? Anyway. Good thing that we have good food standards here, I guess. So, maybe that was just for show for people so they could see it. Maybe they don't actually maybe they have better vats that they make the actual cheese that they sell in. We tasted the cheese when we went downstairs. Yeah. I didn't taste any crickets. But that being said, yeah, eating bugs is a big thing, is becoming more popular these days, and in lots of places in the world, including Africa. I also spent some time in South Africa, and absolutely, they eat bugs all the time there. Like, if we walk downtown, we were in the capital city of Zambia, which is Lusaka. If you walk downtown, you would see people just sitting on the street selling bananas or fruit or bugs. Like, they would have big, like, larva bugs and worms and all different kinds of things that you could buy, and people eat them regularly there. It's no big deal. I mean, it's no different really than eating meat or anything, right? Like, it's the same thing. It's just what you're used to. Anyway, there you go. So back to our question. What are we talking about here? A 2-meter long arm in a vat rotates 3 times around in 1 minute. So the arm in the vat is 3 meters long, and it goes 3 times around in 1 minute. What is the angular velocity in radians per second? So if it goes 3 times, we're just going to think about this. This is what you have to do. Like, I'll show you kind of how you could set up and show your work, but these questions to me are less about showing your work. Still try to show your thinking, but there's no like one way that you solve these. To me, I try to use proportions. I think about proportions. That can be helpful, but a lot of it is you're just going to kind of use some common sense, some logic. If it goes around 3 times in 1 minute, how many radians is that? I heard somebody saying something about it. 6 pi radians, because once around is 2 pi, so 3 times around would be 4 pi and then 6 pi, right? Good. So if it's 6 pi radians in a minute, how much is that per second? Because we usually measure angular velocity in radians per second. So then you just have to convert it to seconds. So like, I'll show you how you can show your work, but if you can kind of, so there's like how many seconds in a minute and then just figure it out. Yep. Pi over 10. Is that what it works out to? Over 60. Yeah. And then if you might need it in decimals, but right. Okay, so this is not necessarily how you have to show your work, but this is one way that might work for some people. Okay, how far is 3 times around if 2 pi is 1 time around? Might not always be friendly numbers that you can just reason through. So something like this, and then multiply by 3 is how you could kind of set it up. 3 times 2, it gives you the 6 pi. So what is this? This is the total distance. Oh, sorry, not distance. Total radians that it's traveled in a minute. Okay? And then 1 minute equals 60 seconds. So how far does it travel in 1 second if it travels 6 pi in 60 seconds? If you think this is overdoing it, like, yeah, I don't really need, like, I don't understand the thing that you're doing with the proportions, that's fine. Like I said, that's fine. But what you're doing in your head is just a proportion, right? So this works out to pi by 10, which is approximately 0.314 radians per second, right? Hopefully that makes sense, but like I said, then the question in the textbook asks it in a slightly different way, and you're like, oh, now, but it's different. Yeah, it is. They're all a little bit different, and you got to figure out how to think about it on your own and work through these. It's not the kind of it's not like your typical question where I show you how to solve it and then you just do it 10 times. That's not how these work. But think about it. Think about what a radian is, arc length to the radius ratio. Like, think about those things. Think about what angular velocity means. That's something really that you could think about. That's not the distance that something is traveling. That's how many degrees or how many radians it travels in a particular time. How far does the tip of the arm travel in 3 minutes? So again, there's a different order that you could do this in. I'm going to start by figuring out the distance around the exterior. So the end of the arm, what would it travel with 1 rotation? 2 meters long. So I'm going to go with 4 pi. We like to keep things in terms of pi until the very end. Like if it says, put your answer in 2 decimal places at the end only. Keep pi to the very end. Okay, so that's just the circumference. And then, let's see. So that's once around, but how far is 3 times around if 4 pi is 1 time around? Like again, you could kind of just reason through that, but there's the proportion that solves it. So x equals times 3 times 3. So that's 12 pi. So this is the distance in a minute, or 60 seconds, or whatever you want to call it, right? But now it says in 3 minutes. So how far in 3 minutes, if it's 12 pi in 1 minute, .36 pi, which works out to about 113.1 meters. Therefore statement, right? Because so you might have also, you could just do this. It travels 3 times, like you might write, not this whole sentence, but somehow communicate, well, it goes around 3 times in a minute, but it's going 3 minutes, so that's 9 times around. So just take your 4 pi times 9, right? Like you don't have to do it in this order, but you do have to show your thinking. If you just write 4 pi times 9 equals 36, I'll be like, well, wait, where did those numbers come from? So try to show your thinking somehow, but every one of these questions is a little bit different. There's a couple in there, give them a try. Any questions?